Hello and welcome to my YouTube channel. Today we are going to see how we can implement analog to digital conversion on STM32 6RE Nucleo board. In the previous part, we have discussed the concepts related to analog to digital conversion. Today we are going to see how we can implement the A to D or analog to digital conversion on STM32 6RE microcontroller board. So to start with the programming, we are going to follow some steps. First, we will be selecting the ADC channel on which we want to perform the analog to digital conversion. For that, we will be using STM32 CubeMX for initializing and configuring the A to D. STM32 CubeMX is an integral part of STM Cube IDE. Secondly, we will be declaring and initializing a variable to store the value of analog voltage which is received at the ADC channel number 1. Then we'll be enabling the ADC channel 1 and start the conversion. And then we'll be performing the polling operation to read the value of analog voltages. And then ADC will be converting it to its equivalent digital value. After that, the converted value will be stored in the variable which will be printed in the STM32 CubeMX IDE. At the end, we will disable the ADC and stop the conversion. And last but not the least, we will repeat step number 3 to step number 6 continuously in an iterative manner in a while loop, so that the conversion will keep on continuing and we will be able to receive, or we will be converting the analog values continuously to its equivalent digital value. Now let us see the connections that we have to make. To get the analog values, we will be using potentiometer. Potentiometers have 3 legs. Leg number 1, leg number 2 and leg number 3. So leg number 1 will be connected to VCC, or we can say positive voltage. Leg number 3 will be connected to ground, and leg number 2 will be connected to the output terminal which will be connected to the ADC channel number 1. To connect with the board, we will be using Nucleo 6RE microcontroller board, and the connection will be made as shown in the presentation. So plus 5 volt from the board will be connected to leg number 1. Ground will be connected to leg number 3, and A1 pin will be connected to the center pin or output pin of the potentiometer that will receive the analog signal. And now let us try to start the STM32 so that we can start the programming part. So I am opening the STM Cube IDE. It will take maybe few minutes to start the IDE. And in the previous slides or in the previous presentations, I have discussed about the STM Cube IDE, how we can configure it and how can we make projects in the STM Cube IDE. Let us open, or we can start a new project. For that, click on Files, New, STM32 project. And it will start initializing the target selector. Target selector will help us to select the particular microcontroller or microcontroller board on which we want to perform the programming. This may take maybe few seconds to complete. Here we can select either the microcontroller or we can select the microcontroller board. In my case, I am selecting the microcontroller board, and here I can type Nucleo F44 6RE. You may choose the microcontroller board which you have with you. Click Next. Give a name to the project. For example, we can give ADC underscore read underscore project. Okay, and click Finish. It says initialize all peripherals with their default mode. We don't want to initialize all the peripherals in the default mode. Therefore, we will select No. And then we have to start initializing the peripherals which will be required for our project. In this case, we'll be working with the Cube MX. So at first, we will initialize all the peripherals required in the Cube MX IDE. I don't know, it is taking too much time in this case. Seems some updation is going on. Anyway, now here we are in the Cube MX, and we can go to Pinout, clear all the pinouts and click Yes. So all the pinouts have been cleared. Let us go to the system core. First, we can configure the clock. So high speed clock, we can select ceramic crystal, and that's all. For this window, we will come down to the analog section. We can select ADC, and here we can see PA1. We are going to use PA1, so we can click on that and initialize ADC 1 in 1. And after selecting ADC 1 in 1, we can see in 1 has been activated. And for the configuration part, here in the bottom, we don't have to make any configuration. But anyway, let me just inform you that here we are using 12-bit resolution, which is the highest resolution in case of any ADC which is present in STM32 F44 microcontroller. We are using right alignment, and rest of the things we are not going to change. After this, we can click on this gear button on the top. Okay, for the code generation, click on that, or you can click Save All. It will generate the code. Now we are entering in the C perspective, which is going to allow us to write the codes in C language. So here all the initialization has been activated by the CubeMX, and we can see the clock configuration, ADC configuration, and GPIO configuration. All of them have been completed by the CubeMX. Now we have to write our code for ADC. So first of all, like I discussed in the presentation, we are going to create a variable to store the ADC values. For that, I will come down and use private variable declaration section for the user code. Here I can say I am going to initialize, or I am going to declare ADC underscore val variable. Then after that, in the while loop, in the user code section, we can write our code. So user code begin. After that, click enter, and here first we are going to start the ADC. For that, we can type hall underscore control space. Control space will allow you to see all the functions which are available in the hall. So hall ADC underscore start. We are going to start the ADC. So ADC start, and we'll use the ADC1 handler for the ADC data. Then we can start the polling. For that, we can use hall underscore ADC underscore polling. So poll for conversion, control space you can use, and we have to provide the handler, and then the timeout that will be required for conversion. Let me go for 5 milliseconds and put a semicolon. And now we have to pass the value which is converted by the ADC to the variable. For that, I can use ADC underscore val is equal to hall underscore ADC. Remember, keep pressing control space for the auto completion. Get value. So get value, and here we can pass the handler ADC1. This will pass the converted value to ADC val variable. Now after that, we can stop the conversion. So hall underscore ADC underscore control space stop. So we can pass the handler again and semicolon, and we can provide a small delay after the conversion. Let me take 200 milliseconds delay for the completion of the conversion, and the while loop will keep on repeating the same lines, and we will be getting all the values of the ADCs one by one. Now after this, we can compile the program, or we can build the project by clicking the hammer button on the top. Here we can see there are some errors. ADC val is not available. Let me just cross check. So ADC control space ADC val. Let me rebuild the project. Undeclared in this function. So let me cross check if the here I have missed the semicolon, and now let us rebuild the project, and we can see 0 error, 0 warning. After this, we can connect the board and debug the program. So let me start the camera. Here you can see the board is connected to the PC, and we can click on the debug button on the top and click OK. Now the debugging will start. Click OK. And Once the debugging starts, we have to open a window to see the status of the variable. For that, what we can do, we can go to the live expression window on the top right and put the variable name. Okay, so ADC val, and this variable's value will be printed on the live expression. So the program is waiting to read the or perform the ADC conversion. So let me click on resume button, and we can see on the top right we are getting the value received by the ADC. And let me change the potentiometers knob, and we can see now we are getting a different value from the potentiometer. So we can see here 2700. Let me bring it down, and we can see the value is changing with respect to the potentiometer. So in this way we can implement the analog to digital converter to read any external voltage present in our sensor or maybe any other device. With this, I would like to end the presentation. If you have not subscribed the channel, then I would like to request you to please subscribe the channel and press the bell icon to get the notifications when I post a new video. Thank you and have a nice day.